Galvanic cells use energy released during a thermodynamically favoured reaction to generate electricity. So if we sum these redox half reactions, which occur in separate containers, we get a thermodynamically favoured redox reaction. So at the anode, oxidation occurs. So we use the following mnemonic, An-ox, where zinc is oxidized. And oxidation means a loss of electrons using our all-rig mnemonic. And at the cathode, copper is reduced. So we use red cat to remember this. And reduction means a gain of electrons. And this results in a flow of electrons from a higher potential to a lower potential. Now at the anode, we have an electrode in a zinc nitrate solution. And at the cathode, we have a copper electrode in a copper 2 sulfate solution. So when zinc is oxidized, you have solid zinc converting to zinc ions in the solution. And when copper is reduced, you have copper ions attaching to the copper electrode. So at the anode, you have a reduction of mass, and at the cathode, we have a gain of mass on the electrode. And here we have a voltmeter to measure the voltage. Now when you have excess zinc in the solution, negatively charged ions are attracted and flow from the salt bridge to balance the charge. And at the cathode, you have a reduction of copper ions, so you get positively charged ions flowing in that solution to balance the charge. So you can't really have an open circuit like this, or no electrons will flow. So the salt bridge completes a circuit. And you can also have the liberation of gas. So for example, if you had a standard hydrogen electrode. An electrolytic cell uses electrical energy from an external source, such as a battery, to drive a thermodynamically unfavoured reaction. So for example, if molten sodium chloride is placed in a container and we insert inert electrodes, such as platinum, which do not react, and we attach those to the positive and negative terminals of a battery, then the electrolytic reaction occurs and you have oxidation at the anode, which means a loss of electrons, and here negative chloride ions become attracted to the anode and become oxidized to form chlorine atoms, which combine together to form chlorine gas. And you'll see that in the form of bubbles. And electrons from a negative terminal reduce the sodium ions at the cathode. So you get reduction at the cathode, and reduction means a gain of electrons. So here you have the sodium ions, which are attracted to the negatively charged cathode and turn into sodium and play it onto the cathode. Consider the following galvanic cell, which is driven by the following redox reaction. And in part A, we'll determine which species is oxidized or reduced at the anode. So at the anode, oxidation occurs. And now let's write the redox half reactions. So assigning the oxidation numbers, zinc goes to Zn2+, And oxidation is a loss of electrons, so we add those to the right here. And the copper cation gets reduced. So given that oxidation occurs at the anode, zinc is being oxidized. Indicate the direction of flow of electrons from the salt bridge. Well, given that zinc is being oxidized, you're going to have more zinc cations in the solution, and therefore the chlorine ions from the salt bridge flow in this direction to balance a charge. And copper is being reduced to copper solid, so therefore more positive ions flow from the salt bridge in this direction to balance a charge. And which electrode gains or loses mass? Well, zinc is being oxidized, so the electrode loses mass, and copper is being reduced to a solid at the cathode, so this electrode gains mass.